I'm your host, Dr. D. Welcome to Math in the House. Today, we're doing Math Analysis, Chapter 7, Section 1, Oblique Triangles, and the Law of Sine. I'm your host, Dr. D. Okay, now, we have been able to solve triangles when they're right triangles. But what if we have a triangle that's not a right triangle? Not a right triangle? Okay, yes. So, the law of sines applies to any triangle, not just right triangles. So, this is the law. Yes, the law of sines.
Just the facts, ma'am.
Okay, the law of sines says that sine of any angle divided by its opposite side equals sine of another angle in the triangle divided by its opposite side, which equals sine of the third angle divided by its opposite side. So, sine of A divided by A equals sine of B divided by B, which equals sine of C divided by C. So, when is this going to be useful? Well, you have to have some angle and its opposite side, and then one other part of the triangle. So, when do you have that? Well, this will be useful when we have angle, side, angle, 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 side, or angle, side, side. Do we have that in a Christian school? Yes, we do. Okay, so angle, side, angle. Notice if we have any two angles, that gives us the third angle. And if we have all three angles, then, and one side, then we can get the other two sides. Same thing with angle, angle, side. We have the third angle, because we know it all adds up to 180, and then you have one side, which means you have all the rest of it. Now, angle, side, side is going to give us some problems, and we'll deal with that in just a few minutes. Bam! Do we have that in a Christian school? That's annoying. Hold on. All right, so here's an example. We've got right here, angle, angle, side. So, like I said, 100 plus 65 is 165, and so the third angle we know has to be 15 degrees, so that all three angles add up to 180. Now, we have angle B and side B, so sine of 100 over 20 equals sine of 65 over A. And so to get A, we just cross multiply. So basically A is going to equal 20 times sine 65 divided by sine of 100. So we go to our trusty calculator and we punch out sine of 65 degrees. Now remember, it's degrees, so you need to go to the mode and make sure you're in degrees. So I'm going to go 20, enter, 65 sine times 100 sine divide. And that equals 18.4. inches. Now we do the same thing with side C, because we know that sine 100 over 20 also has to equal sine of angle C divided by side C. So that means side C is going to equal 20 sine 15 divided by sine 100. So we crank that puppy out and we get 20, enter, 15 sine times 100 sine, divide, bam, 5.256. So we're going to make that 5.3 inches. Now the last thing you should do is look at it and make sure that makes sense. If side B is 20, side A looks like it's a little less than side B, which works, and side C is much less than side A or B, and it does look like it could be 1/4 of this side. So that's it. Game over. All right, now, next example is going to be similar because we have two angles. This is side angle side. Well, 20 plus 30 is 50. That makes this third angle 130. So we're going to go sine of 130 over 25 equals sine of 20 over A. So I'm not even going to write this step out. I know I'm going to go 25 times sine of 20. So 25, enter 20 sine times. Now I'm going to divide by sine of 130. 130 sine divide, and I get A equals 11.16. So 11.2. Oh, this triangle's from France. It's measured in centimeters. Okay. Now I'm going to do the same thing with side B, and that is sine 130 over 25 equals sine of 30 over B. So that means B equals, crank this out again, 25, enter, 30 sine times 130 sine divide, and side B equals 16.317, so 16.3 centimeters. I look it over, and if side C is 25, then side B being 16 makes sense, side A being 11 makes sense. So, that's it. Game over.
Bam! Do we have that in a Christian school?
That's annoying. I told you that the angle side is not really a firm measure of a triangle. In geometry, if you have side angle side or side side or angle or angle side, you have a firm definition of a triangle. But angle side is not firm. You can't prove two triangles are congruent if you have angle side or side angle. Let's see what happens. I'm going to take a triangle where angle A is 30 degrees, angle C, or I mean side C is 10 degrees, and side A is 7 inches. Okay, we'll just go with that. So angle A is 30 degrees, side C is 10 inches, side A is 7 inches. Here we have it. 30 degrees, 10 inches, 7 inches. Now, I could change this triangle without changing any one of those three measurements. What I'm going to do is look at B as a hinge, and side A becomes the door. And I'm just going to rotate side A this way. Notice what I have. I have another triangle where angle A is 30, side C is 10, and side A is 7 still. So notice two separate triangles that both fit the given information. So when you're given angle side side, there could be two triangles, there could be only one triangle, or there could be no triangles at all that fit the data. So how do we determine this? How do we determine it? We're going to take our triangle, angle side side, and notice we have an angle and its opposite side. So we use law of sines to solve for another angle. So you go sine of 30 divided by 7 equals sine of C divided by 10. Okay, this time when I do the cross product, I'm going to solve for C. Well, I end up with 7 sine C equals 10 sine 30. That means sine C equals, sine C alone is 10 sine 30 over 7. Now, to get angle C, I take the inverse sine of the 10 sine 30 over 7. Okay, now, when I do this, I might have no solutions, I might have one solution, and I might have two solutions. So let's see what happens. When I take the inverse sine of a value greater than 1, there's no solution. So if I go C equals inverse sine of 1.2, quit right there, there's no solution. So if the value that you're taking inverse sine of is bigger than 1, you know sine can't go above 1, so that's it, game over. Now, we took the inverse sine of this 10 sine 30 over 7, and we got angle C is 45.58 degrees. Well, here's that angle, 45.58 degrees. Now, we also know that sine is positive up and negative down. So if I go 45.58 degrees over, so notice this angle right here is also 45.58 degrees. Well, now I have another triangle that the sine is going to be the exact same thing. So two possible triangles. Well, let's see if it is possible. What would this angle be? Well, it would be 180 minus 45.58, which turns out to be 134.42. So all we know is that angle C is the inverse sine of 10 sine 30 over 7. That could be either 45.58 degrees or 134.42 degrees. You take the sine of either of those angles, you're going to get 10 sine 30 over 7. Okay, now, how do we know that 134.42 is a legitimate angle? To find out if 134.42 is possible, what we do is add 134.42 to the given angle 30 degrees. If the sum is less than 180, then we know two possible values for C are there. If the sum is greater than or equal to 180, then there can be only one possible value for C. So when we add 134.42 plus 30, then we get 164.42. That's less than 180, which means there's room for a second triangle. So 2 possible solutions. Let's see what those solutions are. Well, the first solution is going to be where angle C equals 45.58. And now we have 2 angles. So we're just like where we were before, is we know 2 angles, so that means we can get the third angle by adding the 2 we know, 30 plus 45.58. Subtracting that from 180, you get 104.42. That's what angle B has to be. Now we're back to law of sines, because we have an angle and its opposite side, an angle, and we want to find its opposite side. So sine of 104.42 over B equals sine 30 over 7. Do your cross product. 7 times sine 104.42 divided by sine of 30 equals B, which is going to be 13.56 inches. Now, what about the case where angle C is not 45.58, but it's 134.42? Okay, well, let's check that out. So now, when you go 134.42 plus 30 and subtract that from 180, you get the new angle B, which I'm going to call it B prime and C prime. The new angle B is 15.58 degrees. All right, now we have the same situation. We have an angle, and we want to find out its opposite side. So sine of 15.58 over B prime, the new side B, equals sine of 30 over 7, just like it did before. And now the new side B is going to equal 3.76 inches. That's it. Game over. So notice this gives us 2 triangles. Remember, if when we took the inverse sine, we ended up with a number bigger than 1, we're done. If we take the inverse sine and the angle ends up being, let's say the angle ended up being 160. When we take the inverse sine, it's 160. Well, now I add 160 plus 30 is 190. Well, that's already too big. So there can't be a second triangle. So that's it. Now, do you think that this would be a good idea to practice this?
That's the smartest thing I've ever heard anyone say about anything.
Yes.
Bam!
Do we have that in a Christian school?
That's annoying.
Hold on. Let's try one more example problem, and then we'll be done with this section. So, we have a map here, and this is a purely fictitious map. I just made this stuff up right off the top of my head. So, we've got Westminster, Huntington Beach, and Irvine. And then we've got Buena Park up here. Now, Westminster is 18 miles from Buena Park. Huntington Beach is 15 miles from Buena Park. And Irvine is also 15 miles from Buena Park. What we want to do is we want to find out how far Westminster and Huntington Beach are apart and how far Huntington Beach and Irvine are apart. So we're going to call X the distance from Westminster to Huntington Beach and Y the distance from Huntington Beach to Irvine. So we want to find X and then find Y. Well, how do we do that? Well, notice what we have. We have one big triangle that we've got angle, side, side. So what I'm going to do is I'm going to go sine of 50 over 15 equals sine of the Irvine angle over 18. Okay, so sine of 50 over 15 equals sine of, I'll call it I for Irvine, over 18. So we're going to go to our trusty calculator, and we go 18, enter 50, sine time. So I just went that way. I divide by 15, and I get 0.919. Now I take the inverse sine of that, and so I turns out to be 66.8 degrees. Now let's just go 817, just to be a little more precise, because we're going to use that number. Now, so I have this angle. Now, if I want this angle down here, all I do is take the 180 minus this, and that gives me 113.183. Now, 113.183 is going to be this angle right here, the angle at Huntington Beach. So now I'm ready to find out what x is. So what I can do is say x, well, let's just put this in here. 113. So what I'm going to do is I'm going to add that to 50, and then I'm going to subtract the whole thing from 180, and I get 16.817 degrees. 16.817 degrees. Okay, so we now have the opposite angle of x, so we can use law of sines to get x. So what I know is 50 and 15 are both given, so we'll use those. Sine of 50 over 15 equals sine of 16.817 over x. So you guys are good at the cross product by now. We don't need to write it out. So we're just going to go, well, actually what I'd like to do is make sure I have the exact angle in my calculator. So if you forgot what that is, you just go through this real quick. 18 times sine of 50 divided by 15. Take the arc sine of that, and you end up with your 66.817. Subtract that from 180. And now I have my 113.183. Add 50 and subtract from 180. And there I have the exact 16.81716.088. So now I take the sine of that times 15 divided by sine 50, and I have x equals 5.665, so we'll say 5.67 miles. All right, now, the next thing we need to do is get y, and so if we know this angle here is 66.817. And we know this angle here has to be 66.817 also, because this is an isosceles triangle. So now we know if we add these two angles up, So what I'm going to do is go back to here. And once again, let's get the exact angle. So it's 50 sine 18 times 15 divide inverse sine. And there's my 66.817. I'm going to double that, so just multiply by 2. And then subtract from 180. And so I get 46.365 degrees. 46.365 degrees. So now what I have is an angle and its opposite side. So I'm going to go sine of 66.817 over 15 equals sine of 46.365, which is right in your calculator now, divided by y. So I'm just going to take what's in my calculator times 15, and then divide by sine of 66.817. Y ends up being 11.8 miles. All right, now you look at your triangle and think, does it make sense that if this is 18, that this would be 5.67? Yeah, that looks like it could be about a third. X could be about a third of 18. And then Y looks like it's about double what X is. So those numbers are reasonable. When I first got this in my calculator, it ended up being 200 something. I automatically dismissed it because I knew it can't be 200. It's not 200 miles from Huntington Beach to Irvine, even on my fictitious map. So that's it. Law of sines can get you a lot of information on triangles that aren't right triangles. So have fun with these.